to expand. Well, I should probably explain dark energy first. Basically, what dark energy is it is a cosmic, is essentially the energy of empty space, which I actually did get into, like the vacuum energy. Well, it's unknown what dark energy really is, but that's one of the most prevalent theories on it. Another idea is that empty space that's not an actual energy, it's just an intrinsic property of empty space itself. Where what dark energy does is, we've noticed, well, I mean other science, like astrophysicists, have noticed that the further they look out, the faster the galaxies are running away, you could say, away from us. And in order to explain this, we had to accept that space itself was expanding. In fact, space itself could expand faster than the speed of light. I'm only going to and it's dark energy that's expanding space. Well, I bet a good example would be like a enlargen button on a photocopier, where if you hit the button enough times, there will be 2 points on the picture that are moving away from each other faster than 1 light second. It's not that the points themselves are moving, it's that the space is expanding. Another example would be like if you pay attention to 2 marbles, right? And when it comes to these 2 marbles, then you start pumping in more marbles. Eventually, you're going to get so many marbles coming in, that more marbles that come in, the more there's exponentially more. Every marble you put in, 2 more fall down, and eventually it's going to accumulate in something where those 2 points, those 2 marbles, are moving away from each other faster than, maybe not light, but are moving faster possibly than light. So, but imagine that instead of it being more marbles, it's the actual space itself which the marbles are sitting in. So that's all I'm going to talk about for dark energy right now, because I have to get to gravitational anomalies on the planet. But I'll cover dark energy in a later episode. So anyway, on to the final topic. Gravitational anomalies. So, the way gravity normally works is this. Objects normally works like this. The gravitational force on an object depends on the mass the object is in proximity to, and the distance between it and that object. So let's say me standing on the Earth. So when it comes to me standing on the Earth, I'm pretty much sitting on the surface, meaning I'm not that far away from the Earth, but with the gravitational center of mass, which doesn't even, or like a gravitational center point, it comes in handy when talking about massive stars orbiting each other. But essentially, like when it comes to the distance between the objects, it isn't like you move away and the strength is two times less powerful. It's actually, if you move 2 feet away, it's 4 times less powerful. Not literally, but that's kind of the idea, where you step 2 and the resulting force is weaker by 4. But generally, it's always the gravitational force is always focused to the center of mass, or the gravitational focal point. So I'm always going to be attracted to the center of the Earth unless I go into space or something and never come back, or something like that. But sometimes this isn't so. It's rare, but it does happen. For instance, I used to live in Florida, and when I was in Florida, there was actually, like, it's called Spook Hill. You know how normally when you walk up a hill, it takes a lot more effort than walking down a hill? And walking downhill doesn't take that much effort. Well, Spook Hill, while it's easy to walk uphill, it's actually just as hard to walk down Spook Hill as it is to. It's like walking up, but you're walking down. And there's an interesting thing what happens when you park cars there. The cars will actually back up the hill. Now, there's plenty more spots like this. For instance, there's the mystery spot. I think that's what it's called. There's a lot of these gravitational anomalies that have gotten a lot of different names, but the mystery spot, basically, it's this very small area. There's like a ramp. You throw a ball on it, and you would think the ball would go down the ramp and fall down on the other end. But what actually happens is you throw the ball, it gets mostly down the ramp, but then it stops and rolls back up and goes back and falls off the top end where you dropped it in the first place. There's another spot in which, instead of being attracted down, like I am now, instead you're attracted to, like, it'd be like me being attracted to the trunk of that tree. Although it's not that extreme, but it's like me standing, like, diagonally and being attracted to the ground with my feet, like this. With my feet being attracted to the ground like this. Like being attracted to a wall. Not much is known. The best explanation we have, I think, is this kind of crap, because these spots are actually real, because not only can they affect real objects, but not just our observation of them, but the actual objects themselves, but it also disrupts equipment. So the best explanation we have right now is that they're optical illusions. Although these would be very specific spots to have an optical illusion, though. So it's highly unlikely, but it's the only explanation we currently have, which is really saying something, because it actually disrupts equipment that's put in that spot, in these spots as well. So that's it for the episode. If you enjoy science content like this, or perhaps better coordinated than this, check out my other videos where I talk about things ranging from quantum mechanics to more details on gravity, to plenty of other interesting things. So check it out. Like this video and subscribe to the channel, and have a good day, I guess. Let the science be with you.